Alright guys, so here's another example. We're given a hyperbola on a graph and they want us to write the equation of it in standard form. Okay, so our first step is to determine, are we dealing with a horizontal or vertical hyperbola, right? And looking at this, we can see that it's opening horizontally, right? So this is going to be a horizontal hyperbola, meaning that, okay, it has a transverse axis on the x, right, and a conjugate axis on the y, right? Now, the equation we use for a hyperbola that is horizontal is the following. We have x squared all over a squared minus y squared all over b squared equal to 1. Alright? And remember, this is a bit different than that of an ellipse, because remember, when you have an ellipse, you're actually adding. Here we're subtracting. Alright? And also remember, with an ellipse, your a squared value will always be the bigger of the two denominators. However, when you're dealing with a hyperbola, that won't necessarily always be the case. Right? So how you determine, okay, just by looking at the equation, if you're dealing with a horizontal or vertical, you look for the positive variable. So in this case, right, if I look at x here, I know it's positive. That's going to tell me that this is going to be a horizontal hyperbola, right? If y was positive, which in this case it's not, but if it was, and my x was negative, then it would be vertical, right? So for example, a vertical hyperbola, right, the equation would look like this. You would have y squared all over a squared minus x squared over b squared equal to 1. This would be vertical, right? Y is positive, vertical, x is positive, horizontal, okay? So why don't we go ahead and identify our values. We know that this is the standard equation of a hyperbola that is horizontal. So if we can find the vertices on the transverse axis, right, that is going to be our a value. So for example, if we count here, this will be negative 3, 0, right? And this will be 3, 0. Now it doesn't matter which one you pick, because think about it, if you plug in negative 3 into a, negative 3 squared will be 9. Right, 3 squared is 9, so it doesn't matter. So we just plug 3 in and we're going to get 9. So we have x squared all over 9, right, minus, and I'll have y squared all over. Now let's find our b value. Again, that's going to be your co-vertices occurring on the conjugate axis. So in this case, here's our conjugate axis on the y. Alright, so this is going to be, right here is going to be 0, 3, right, and this will be 0, negative 3. Again, you can pick either of the two, because you're squaring it, you're going to get the same result. Right, so we know that 3 or negative 3 squared is going to be 9, so this will also be 9, equal to 1. This right here is your equation of this horizontal hyperbola. Okay. Now there's a couple of other things we can do here. We can go ahead and identify where the foci is occurring. And in order to do that, we can use the following equation, right? So that equation, because remember, there's a relationship between the vertices occurring on the transverse, the co-vertices occurring on the conjugate, and the foci. And that relationship is the following when dealing with hyperbolas. You're going to have c squared equal to a squared plus b squared, right? Remember, when you're dealing with an ellipse, it's the same thing, except you have minus b squared here, right? So let's go ahead and just fill in our values, and we'll find c, which is going to be our foci, right? C is our foci, a is our vertices on the transverse axis, b is our co-vertices on the conjugate axis. So all I have to do is plug these in. So let's do it in a different color. We can have c squared equal to, well, a here, we already determined is going to be either negative 3 or 3, right? It doesn't matter, so we'll get 9. Plus, right, b squared, which in this case will be, again, either 3 or negative 3, so 9. Right, so we get c squared equal to 18, sorry. And then we take the square root on both sides. Right, so c will equal plus or minus. So if we take the square root of 18, we get plus or minus 4.24. Okay, and that makes sense because we know that the foci actually occur on the inside, right, of these outward facing parabolas, right? So this will be, right, we just put 4 Alright, so if we go ahead and put this in, we'll be right about here and right about here. So that is where our foci is going to be occurring. Alright. Now there's one last thing we can do here, and that is find these asymptotes that are occurring. And again, this is fairly easy. There's an equation we use when you're dealing with horizontal. That equation is going to be the following. We get y equals plus or minus, and this will be b all over ax. Okay, so all we're going to do is plug this in. We know that b, okay, in this case, is going to be right here, so we're going to get 3. Our a, again, will be 3. X, you know that 3 over 3 is just 1, so we get y equals plus or minus x. Okay, so that is where our asymptotes are occurring. Alright, and that is it.